Morning, it's Craig from Yesway Communications here, and we're going to have a look at software-defined radio. Now, this is just a quick demonstration. We're using a SDR software-defined radio dongle, which is basically the receiving part of it connected to an indoor antenna, and that plugs into our laptop. Now, we have the software on the laptop. It's called software-defined radio for a reason. The clues in the word software. So rather than traditional radio where you've got a lot of the electronics, as there's a lot of blocks within the radio system, blocks of electronics doing different things like the IF stage, power amplifiers, etc., audio frequency amplifiers. Instead, it's done using the laptop and processing it in software instead rather than physical hardware. So you can see on your screen we have a piece of software loaded up. We're currently on, if you look where the cursor is, hopefully it's recording this, it's on 145.337.5 megahertz. Okay, now this is the amateur radio frequency, or ham radio if you're from the USA. So let's turn this on. Press the start button. Now, you can see here there's a signal. Let's see if we can pick it up. I just realised I'm not going to the volume, so I've got the microphone plugged into the microphone and speaker port. Right, let's see if I can do something about it so I can actually hear what's going on. Speakers. Try that. That's better. Okay, I can hear it now. And we're getting some noise. I hope you can hear that on the recording. Oh, right. Well, this NFM up here, where I'm pointing with the cursor, narrowband FM. We've got AM, amplitude modulation, LSB, lower sideband, if you're following where I'm pointing the cursor on the left-hand side here, USB, upper sideband, WFM, wideband FM, the FM being frequency modulation, DSB, double sideband, now CW, carrier wave. They'll have, well, I know it's carrier wave. There's something else wave. I can't see the other one people call it, but basically, I know it's carrier wave. The wave that the signal's carried on, carrier wave. Right, and raw, just a raw output. What's on the channel? Not a lot. Let's put it back to narrowband FM. Now there's something there. Let's just Now it could be because you see this where this we can narrow it in. So we're changing the bandwidth. There we are. So it's bandwidth 20.81 kilohertz. That's how wide our channel is in effect. So if we narrow it down, is that going to make a difference? Right, it's going to be 12.5 kilohertz. Oh, there's enough channel bandwidth. Well, assuming we're receiving an analog signal on the amateur radio frequency. Nothing there. Right, let's just have a look around. It's fairly quiet on there. Now, have we got all the settings correct? Some point. Well, that's a bit better. Okay. Sort. Set it to that. So, Right, so we're on 144. Let's take it to 145. Right, let's get some music on here. So we're going to lower this to, let's go for 102. We should be around the broadcast bands here. Ah, there's something there, definitely. Let's get the volume up. Now, you can see up the top left here, we're on WFM now. It's automatically changed to wideband FM because this is the broadcast band, like your FM radio, and the bandwidth is much wider than, say, two-way radio. Just not sure I got no sound again. Oh, we have. There's something there. Hopefully you can hear that. We've got some classical music. Just getting that to roughly the signal bandwidth. Right, well, we've got music. It's not very loud. I'm not quite sure what I've got turned down here. But you should be able to hear music. Oh, I've lost it again. There we go. Now, stereo. Let's have stereo. Yeah, so you can see the signal there. This whole screen is like a big mine's gone blank. What do I mean? I don't mean frequency counter. I mean I've forgotten the name of it. What do I mean? But what this is showing, spectrum analyzer. That's the word I'm looking for. I need another coffee. Spectrum analyzer. So the spectrum being the frequency spectrum. So we can see we've got a signal there. We've got one over here. One pointing the arrow. Let's see if we can get that one. Probably should have set this up before I turn the camera on. What else we got here? 99, 98. There should be something there. What's this? Is that radio 1? That's better. Right, so hopefully, if this video is working correctly, you should hear some audio. I think that's radio 1. So that's the FM broadcast band. Now, the beauty of software-defined radio is, like I say, you're not restricted by the hardware constraints of hard-wired electronics. So you might this is why satellites are increasingly using it, because if you send a satellite up to space and it's designed to work on certain frequency, certain bandwidth, etc., and you want to then change something, now it's a bit difficult if it's, well, 1,000 kilometers up in space, less than 2,000 if it's a low Earth orbit satellite, or 36,000 kilometers away if it's a geostationary satellite. It's not easy. In fact, nigh on impossible. It's not going to be viable to do it. But if you've got software-defined radio, you can change the parameters remotely. So that's why they're using these receivers on them. And well, they're using them in all sorts of applications, because you can change the frequency remotely. I mean, that does, I suppose, have some security implications potentially, but right, I'm just going to show you. So we're on 98.9 megahertz at the moment. So if I just click that, we're suddenly on 198. Right, 868. Right, this should be, it's known as the ISM bands, which stands for Industrial, Scientific and Medical. What's that there? And in Europe, LoRaWAN, for instance, which is a technology using IoT in the Internet of Things, that operates on these frequencies. There we go. There. Where's it gone? I keep seeing. I was something a minute ago. I've lost it now. So this right hand side. See some of these signals. There's one there. Keep appearing and disappearing. They're data signals, and they're intermittently sending their data. Right. There's one. I'll leave it where we are at the moment. I just heard something. Oh, there's one. Right, we get the idea. Now if I swap down to, let's see, 168. Right, I'm going to leave it there, but you get the idea of software-defined radio. So rather than hardwired electronics and fixed parameters, it's controlled by the processing power of the computer. So you've got a basic receiving unit, which is receiving the RF signals, but a lot of the processing of that would normally be done with electronics is done in the software of the computer. So that's what software-defined radio is. Right, I'm just going to turn that off now. Off. Right, okay, this is Craig from Yes Way Communications. I hope you found that interesting, and thank you.